What's up, guys? It's Mr. Bringle, and today we're going to be talking about gravity and a little bit about projectile motion for ICP. So, jumping right into it here, gravity is the idea that any two masses that exert an attractive force on one another. And this would be best described, obviously, with our solar system and the giant, massive sun. And it has this gravitational pull that keeps all of the planets in orbit. But then, even on a little bit smaller scale, but still a very large scale, you've got the Earth, and it keeps the moon in orbit with an attractive pull. So gravity depends on the mass of each object and the distance between them. And obviously, larger masses are going to have a greater attractive force. Now, what I'd like you to do is I'd like you to go ahead and pause the video, and then on your Google Slides, I want you to click on this link right here for the Eureka Gravity video, and just watch that real quick. That'll be a good little informational video on gravity, and then come back here, and I'm going to keep talking about mass and weight. So mass is the amount of matter in a material, and that's measured in kilograms. We've talked about mass before, but what's confusing is the difference between mass and weight. And this is a commonly mixed up and a misconception that, you know, they're the same thing, or that weight is measured in kilograms, stuff like that. So weight is actually how gravity acts on, or a measurement of how gravity acts on an object's mass. So it uses an object's mass to calculate it, but it's actually a force. So weight is measured in newtons because it's a force. So when you step on the scale to see how much you weigh, it is actually measuring a force at which you are pushing down on the scale. And there's little springs in the scale that help measure the force that's being pushed down on it. So your mass never ever changes. Okay, your mass is always the same. That's the amount of matter within you. Well, your weight could actually change because the force of gravity, the acceleration that's caused by the force of gravity, which we'll learn here on the next slide, can change with location. So like, you're going to feel less weight on the moon than you do here on Earth, right? And that's evidenced by, if you've ever seen videos of people moonwalking, they kind of bounce, right? And they float. Well, that's because they have less weight on the moon. So at this point, I'd like you to pause the video again. I want you to click on the link for the Eureka mass versus weight video, and I'd like you to watch that. And then we're going to keep moving here. So lowercase g is the variable for acceleration due to gravity. So it is a measurement of acceleration. So it's measured in meters per second squared. And this is essentially, if you were to drop something in air, how quickly will it accelerate as it moves down? Now, technically, this value is 9.81, etc., meters per second squared. But in this class, we'll go ahead and round up to 10 meters per second squared to keep calculations simple. So on Earth, objects will accelerate when dropped in the air, going down, or when you throw an object up in the air, they'll accelerate at 10 meters per second squared. That means each second, that object that you drop, if I drop this pencil, every second, this object will increase its speed by 10 meters per second. So if I drop it initially, it's at 0 meters per second, and then it starts falling. After 1 second, it should be moving 10 meters per second. After 2 seconds, it should be moving 20 meters per second. After 3 seconds, 30 meters per second, and so on and so forth. Now, this is only on Earth because the acceleration due to gravity changes with your location. And technically, we can get differences in this number even at different places on Earth based on altitude. But really, where you're going to see the biggest difference is like, changing planets or going to the moon. So the moon has a different acceleration that's caused by gravity. The Mars has a different acceleration that's caused by gravity. So things will accelerate at different rates depending on where you're at. Okay. So an object's weight is its mass, so the amount of matter that it has, multiplied by the acceleration due to gravity, or the acceleration that's caused by gravity. So weight is a force. And remember that equation that we've already learned about, F equals ma. Well, weight is a force that's a mass times a specific acceleration. So we would just kind of sub in lowercase g for this one when we're talking about weight. So it becomes weight is equal to mass times acceleration due to gravity, or F subscript g is equal to m times g. So weight is a force. And you can see the different values here of the acceleration due to gravity between Earth and the moon. You can see things accelerate a lot slower on the moon. And that's why you're going to see somebody float, because they're not being pushed down back towards the surface as aggressively as they are on Earth. So we could do, a whole big long multiple lectures on projectile motion, and when you take regular physics, you'll probably you will do that. But just very simply here, projectile motion is affected by gravity. So we're going to talk about it just briefly. A projectile is anything that's thrown through the air. So if I take the pencil and I throw it, you see that arced motion, right? It comes back to me. So I put some sort of horizontal velocity on it, and it arcs through the air and comes back down. Okay, so it follows a curved path, and there's a picture here of the water being shot up. Well, that's because, and I'm kind of going over here to the vertical motion part, that's because gravity is pushing it down, right? So like if I throw this straight horizontal, it still takes that curved path down. Well, that's because gravity is constantly pushing down on this pencil as it's moving. Otherwise, this pencil will just travel horizontally, right? It would just go straight through the air, but something is pushing it down, and you can't see gravity, but we can tell that it's working. So there, with projectile motion, when you launch something at an angle, there's an aspect that's also horizontal motion, right? So we've talked about Newton's 3 laws of motion. And Newton's first law states that an object in motion will stay in motion in a straight line at a constant velocity until it's acted on by an external force. So if there was no air resistance, if there was no gravity, and I threw this pencil horizontally, it's just going to continue horizontally at a constant velocity until the end of time, unless something acts on it. Now, you would see this, the only place you would actually see this would be in outer space, right? Like you could actually throw that pencil in outer space and it would behave like that. On Earth, we have air resistance, so it's going to slow down, of course. We also have gravity, so it's not going to go straight. It's going to be pushed down, right? So that horizontal force is something that I apply to the object. The vertical force that acts on it is from the Earth pushing down. And so that's why you're going to see that curved path there. There's obviously a lot more that has to do with projectile motion, but that's just a brief introduction to it. Make sure to fill out your notes, and we'll actually do some activities with these things in class.